So we're now going to change from finding the derivative at a specific point A. Remember, A was always just a number. Now we're going to leave it as an x. So we'll have a function that will tell us the derivative. So we can put in any x value to find the slope of the tangent line. Okay, so let's do it for this function right here. So f prime of x will equal, and we're always going to use the definition with h when we're doing this. So we'll put x plus h everywhere there's an x, and then carry along the positive 4, and then we subtract off the function, which is just x squared plus 4. And don't forget the parentheses, and then that's all over h. So I'm going to multiply that out. So x squared plus 2xh plus h squared plus 4. And then I'm going to distribute this negative sign. So negative x squared minus 4 all over h. So let's see what cancels here. So I see the x squareds are gone, and the 4s would go away. So let's see what we've got left here. We've got a 2xh plus an h squared left in the numerator, and then an h. And you know it would be really, really bad math to just cancel one of those h's. So what's necessary to do is to factor an h out. Then those two things will cancel. So I'm left with the limit as h goes to 0 of 2x plus h. And now I ask myself the question, remember it's still a limit, can I plug in h equals 0? I can. So what am I left with? 2x. So what that means that this is the derivative, kind of like a formula. So if I'm looking at this graph here, this is the derivative for any point x. So let's just graph f prime of x. So that's just 2x, right? So that's a line, slope 2, whoops, go through the origin. And if I was to graph x squared plus 4, f of x squared plus 4 looks like that, right? Okay, so let's think about, this is where we're going to be heading into, I'm just going to start to tease it out. So if I was to look at the point x equals 0 and draw a tangent line, that tangent line looks like it has slope 0. So at x equals 0, the slope of the tangent line is 0. That's what this says. So if I was to pick a point like x equal 1 and draw a tangent line, right there, oh my, I think that's some kind of positive slope, isn't it? So if I go to the point x equal 1, it's some positive slope. Okay, so let me just play with one more point. If I pick a number like negative 1 and draw a tangent line, it's got a negative slope. If I got negative 1, it's a negative slope, because this y-axis is really the slope of the tangent line. All right, so let's try another one. Use the definition. This time we're just doing g. So we're going to find g prime of x. So limit as h goes to 0, 1 over x plus h minus 1 over x all over h. So you recognize this problem. We've had it in the limits. So we know we are to multiply the numerator and the denominator by the least common denominator. Okay, and you cancel as you go. So you know that when you multiply this term times those two, the x plus h's cancel, so you're left with an x. And then when I multiply this times this, the x's cancel, so I'm left with x plus h, and be really careful with that negative sign because it has to distribute. And you never, ever, 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 ever multiply the denominator out. So what can happen here? So you know you cannot, right? I'm just going to keep reminding you what really bad math would be. To cancel those two is really bad math, right? So you're going to take the time to multiply that out in the numerator. So hx plus hx. Oh, look at that. The x's are gone. So I'm just left with a negative h in the top, hx plus h and then an x. So now I see that the h's will cancel. And what am I left with when I cancel in the numerator? I'm left with a -1, right? And then I'd have x plus h times an x. Now I ask myself the question, can I plug in h equals 0? I can. So when I plug in h equals 0, I get -1 over x times x, so that's x squared. So that's the derivative. Okay, we know what that graph looks like. So that's just the 1 over x squared graph flipped over the x-axis. So that's g prime of x. And if I was to go back and draw g of x here and here. Okay, so we've talked a lot about how the graph of the function has to be continuous in order for there to be a tangent line. I can tell that g of x has an asymptote, so there's no tangent line at x equals 0. Oh, look at that. There's no tangent line at x equals 0. There's no slope of the tangent line at x equals 0. So we'll continue on with this idea.